Morning all. Let me set my fiddle aside, and behind me I have a light curtain emitter and a light curtain receiver that we're going to test. This light curtain is the emitter and this light curtain is the receiver. Now on the receiver side we have two outputs for this brand of light curtain, for this model of light curtain. And these two LEDs and their current limiting resistors represent one output and the other output. Here is the reset switch, and after the light curtains are powered up with plus 24 volts DC, we'll have a blinking reset LED on, and I will reset the receiver. And then I'll place my hand down here, and the outputs, the two LEDs representing the outputs, will turn off. So let's turn on the system, let it boot up. You'll get some video of the receiver and the transmitter booting up in just a little bit. Okay, let's reset the receiver, and the two LEDs representing the two outputs have turned on. Now let me block the light. Look at that. They have turned off. Now to get the system to come back up and the two LEDs turn on, you have to reset the receiver again. LEDs off, reset, LEDs on. Now, let me move the camera and we'll see. It's going to be a little bit difficult, but we'll see if we can get a video at power up of the system and while it's operating of the receiver and the emitter. Okay, we're looking over the shoulder of the emitter into the receiver. Let's power up with plus 24 volts DC. Now we'll reset the receiver. I don't know if you can see it, but there in the background are the two LEDs. Let me block the light from the emitter. The two LEDs went off, and you see that bar graph right there? The green and red bar graph? That shows what section of the receiver has been blocked from IR from the emitter. Isn't that amazing? There's my finger right there. That's amazing. Now the problem with this system, on the receiver side, one of the outputs shorted. And I'll show you the parts that I replaced. I replaced a transient voltage suppressor, a P-channel MOSFET, and an NPN transistor. Let me flip the camera around to the other side and we'll see how the emitter boots up. Let's power down. I'm going to try to hold this steady while we apply 24 volts DC to the emitter. That's fully booted up. The light is not blocked between the emitter and the receiver. Now the infrared light has been blocked and the two outputs of the receiver have turned off. Let's reset the receiver. Let's block the infrared light. Reset the receiver. Blocking the infrared light again. That output has been repaired. Here are the three devices, surface mount devices, that failed. This is a transient voltage suppressor. Right here is the P-channel MOSFET, and there is the NPN transistor. And I'll put part numbers up of these devices that failed. There you are. There you are. Not a hard test to perform. The hardest part was finding socket pins and wires that I could slip up into that connector right there. Not a lot of room there. I wished I had the connectors for everything I worked on, but I would have a building full of connectors. So you have to improvise and make do, as always. Alright folks, I hope you enjoyed that video. That's a lot of fun to work on these light curtains. It's a little bit difficult getting them apart. You have to pull the end caps on both sides, and then I'll put some pictures of what's inside. And then when you get the two end caps off, you push the circuit board with the receivers and the control board out through the connector side. Makes it a little bit difficult to get these things apart, but not too bad. Alright all. Have a good day. Enjoy your Saturday. It started to get cold a little bit out there. We'll see you next time. Good morning all. Here's day 2 of testing the Easy Screen light curtains. Now, yesterday at the output, the two outputs of the receiver, we had LEDs and current limiting resistors to simulate the load. Today I have two 24 volt relay coils connected to the two outputs. One for one output, the other for the other output. The light bulbs are across the contacts, the normally open contacts of the two relays. So this light bulb will be turned on by this relay, and this light bulb will be turned on by this relay. So when these relays are energized and the contacts are closed, the two light bulbs will be on. And these two relays will be energized, the coils of the relays will be energized by the outputs of the receiver. So we already have 120 volts AC applied to the light bulbs and contacts. I'll show you a drawing of that here in a little bit. And we're going to apply 24 volts DC to the emitter and receiver. Oh, let's try it again. There we go, it's booting up. I had the reset switch closed. Alright, it'll be up in a little bit. There we go. The system has initialized. I'm going to reset the receiver and its outputs and turn on the two relays. The two relay contacts will close and the light bulbs will turn on. There we go. Now, I'm going to block the infrared light. The relays have opened up, the light bulbs are turned off. Let's reset the receiver again. Let's interrupt the infrared light. Reset the receiver. There we go. Now that proves to us that the outputs of the receiver can turn on a relay load. Nice. Now, at the end of the video, I'll put up all my drawings so that you can test your light curtain of this model. Hello all, let's take a look at my drawings. Now here are the two outputs, OSSD1 on pin 5, OSSD2 on pin 4. The parts that failed, I don't have this circuit down here drawn out as detailed as this one up here. This is the circuit that failed, but the parts that failed were this transient voltage suppressor, marking code CK, manufactured by Diodes Inc. And this P-channel MOSFET, part number IRF R2120, and this PNP transistor, part number FZT751. I don't have the whole circuit drawn out. I'm sure there's resistors, biasing resistors right here, pull down resistors, resistors over here, resistors in the emitter circuit. There's no need to completely draw out that whole circuit. You only want to draw the parts that had failed to see how the circuit functions. Now, we have plus 24 volts DC up here, and when the P-channel MOSFET is turned on, that voltage is applied to pin 4. And we had our green LED and current limiting resistor out here going to ground, this ground right here. On the second day of our test, we had a relay coil out here, 24 volt DC relay coil out here, pin 4 going to ground, pin 6. The 24 and ground coming from an external power supply to power up that transmitter and receiver. Let's go look at our second page. Are we still in the frame? Let me take a look. Looks like we are. We have a circular connector with 8 pins. 1, 2, 3, 4, 5, 6, 7, and 8. pin 1, we applied 24 volts DC to pin 1 and ground of that DC external power supply to pin 6 to power up the transmitter and receiver. The transmitter, I don't have it drawn out, this is the receiver, but the transmitter powers up with the same inputs of 24 volt DC and ground to pins 1 and 6. That would power up the transmitter. Here is the output. Pin 4 had that connected to K2 and pin 5 connected to K1. Now 2 and 3 in the data sheet, they're shown jumped together on one of the PDF pages. They call this external device monitoring. And in one of the circuits, we just jumped it out. So that's what I did with our test. Here on pin 8 is the reset input to reset that receiver. Here's a little push button. One side of the push button tied to 24 volts DC. That's this 24 volt DC up here from the DC power supply, that external power supply. Push that button, it applies that 24 volt DC to pin 8, reference to ground of course, and that resets the system, the receiver. So after we apply the 24 volt DC to that receiver, we wait for it to boot all the way up, we press the reset, both outputs apply 24 volts DC on these two pins, these two outputs, and energize K1 and K2, or the green LED and current limiting resistors. Let me draw that in there. Hold on a sec. So here we had, if I can do it without making a mess, we had what, 1.2 kilo ohm resistor for 24 volts, thereabouts. So either the relays were energized or the light bulbs were turned, or the LEDs were turned on. When the relays were energized, the contacts closed and the light bulbs turned on. Let's go and look at that page. Here's the K1 and K2. This is day 2 of that test where we used relays instead of LEDs at the two outputs. So when output number 1 and output number 2, OSSD1 and OSSD2, turned on, K1 and K2 energized, the K1 and K2 contacts closed, and we had hot flow through the light bulb to neutral through the relay contacts. Here in America, 120 volts AC, single phase. There you go. I think that's everything. I think that's everything. But you fixed it. You fixed that one output that was shorted on the receiver side. Good job, folks. Good job. I'm proud of you. You did really good. We'll see you on the next one.